I'm going to be talking about Dist Zilla. Before I get started, I would like to know who uses or knows Dist Zilla already? A few. Okay. So first I'll talk about what it is. Dist Zilla is awesome. That's it. Okay. This is me. Maybe you saw me this morning. I write a lot of curl. I like to eat cake and pie, and drink cocktails and beer, and shoot zombies. And I like to give away software. And I give away almost all my software on the CPAN, which I love. It's great. But being a CPAN author is hard. So I want to talk about why it's hard, what makes it hard. This is all the stuff you might have in a CPAN distribution. And a lot of this is crap. It's not fun to make, and you don't want to have to do it all. So let's go through it. Let's walk through the list. This file is the file that will build your whole distribution. It does all the work to get things installed. And it might use xutils makemaker. If so, inside it will look like this. It tells you the name, who wrote it, where to find things like a description, what it requires, and so on. All of these things are needed to build the distribution and to install it. And sometimes you want to put even more information, like the license. And when you want to put in a license to make it work everywhere, you need to put in more and more things like this to make it avoid backward compatibility issues. This is a pain. So you might try to solve this problem by switching to something more modern that avoids these issues, like module install. With module install, you write some of the same data, but a lot of it is taken away. There's noise that's taken away. It will look at the pod, and it will find your license there, and it will fill in the license into the file. The problem is, it will turn into extra code that is bundled with your distribution. And if it turns out that you bundled version 1.2 and it had a really big problem, you have to re-release all your software that used that. And it means that you need to add a bunch of extra information to all of your files to make them match. So for example, you've put your license and your author name and the copyright data into your main module. But you have lots of other modules, and you probably need that information there also. So you put it in all these files. But now when you change the license, or add authors, or change the copyright date, you have to edit them all. And you have to put them into every new file you make. So now there's more work to do every time you make a new file. So maybe you turn to another tool, like Module Starter. And Module Starter will make all the files for you and put everything you need in them. The problem is, it doesn't know exactly what you want in every file. It might not know your author name, or a description of the distribution, or what the copyright years are. And it expects that you will fix this. You will start a new distribution, and then you will go in and you will edit all the files to fix them. And to make sure you do this, it adds a test. And this test says, did you fix all of the problems? And you are expected to make the test pass and then delete it. So to use this tool that's supposed to save you work, it's adding extra work to make sure that you've done the work. It's not really a very good savings. Further, it's shipping this pod coverage test. Every time you have a fixed pod coverage, for example, you start requiring a new version of a pod library, you're going to have to go and fix all of those pod test files because they were generated based on the version that your module starter template used. So again, there's lots of extra work that's needed to keep these things up to date and accurate, and it's not automated work. So module starter starts to fall flat. So we've seen there's a bunch of places where you have to write lots of text that's boring. You have to update text to keep it matched between files. You have to delete extra files that were there to make sure you updated the other files. What it comes down to is a lot of busy work. And you don't want to do busy work. You want to write cool code. So Zilla is a tool to try and solve all these problems. And it solves them basically by letting you say, you don't want to store anything that you can figure out at the last minute. So we're just going to delete all these files, and we'll never think about these files again. And we can go through files like these and delete a lot of them. And we're going to walk through the kind of stuff we can do. We can do, Zilla will show, I will show you with Zilla how to update your version numbers, upload stuff to CPAN, automatically tag releases, figure out your prerequisites for you, and lots of other stuff that's really boring and it makes you not want to share your code. When I use Zilla, I have a big set of plugins I use, and here's a list of all the stupid mistakes I make when I'm not using Zilla, that Zilla prevents me from making. I ship prerequisites that don't match the versions I need in the code. Or I require a prerequisite that I've written and installed locally, but not put on CPAN. Or I don't tag my release in Git. Or I don't bump the version in the changelog. Or I put the new version in the changelog, and I don't say what changed. Or I've added files to my project, but I forgot to put them in Git. Or I forgot to pull from GitHub, so whatever work I did from another computer, I don't have in the new release. Or I did a release, but I forgot to push to GitHub. Or it's all on GitHub, but the repository data isn't in my project. Or I documented everything, but my pod is broken. Or my pod is fine, but I didn't link to the bug tracker. These are mistakes I used to make every time that I shipped. And Zilla will fix all of these in a way that does not have you do any work. And that is why Zilla is awesome. And it saves you lots of time that you would have spent doing nonsense so that you can eat cake and pie and drink beer and shoot zombies, and more importantly, keep giving away software. So hopefully you'll take my word for it that it's awesome. The other thing you should know is that Zilla is huge. It has 153 prerequisites. And that number goes up now and then. But Zilla only handles make dist. That is, when you say I want to build a tarball to upload, it does that work. When the user gets the file and says make install, it doesn't do that. The user doesn't have to install those 150 prerequisites. Only you do. The user doesn't see Zilla. They might not ever know that you used it. They see a normal looking distribution that they can use and interact with exactly the same way. So there's no problem like you have with module install, where you've shipped embedded code all over the place that's broken. This is also stupid. It doesn't really do anything. Instead, it's got lots of plugins, and the plugins do all the work. So a lot of this talk is going to be talking about the plugins that exist, how you can build plugins, and how plugins work. Because when you understand Zilla plugins, you can make Zilla work the way you want it to, and not the way I want it to. And the way you're going to use Zilla is by making a configuration file. I wanted to use a file format that was really sophisticated and could handle anything I could throw at it, so I used ini. Everyone likes ini, I hope. Okay, it's probably the simplest thing that I could make work when I was riding the bus and writing the first version. My configuration file looks something like this. I start off by saying, this is a distribution called your dist. I give it a license, and I say who's the copyright holder. And then I start listing plugins. I want to gather files, even .dot files, to be in my distribution, and I'm going to remove files that are probably garbage, and generate a meta YAML and a make file, and things like this. We'll talk about them more later. And I might use a bundle which is a bunch of configuration that works well together to save a lot of typing. For example, if I save typing by putting @basic, I'm really putting all of these plugins in. You're going to see that you use a lot of plugins at once. Here's all the plugins I use in my distribution to automatically figure out prerequisites, to automatically determine a new version, to stick the version into my code, to build a description of all the plugins I used and ship it with the module, to make a meta YAML and a meta JSON, and to update my changelog, and to test my pod syntax, and to make sure that the repository is set, and to rewrite all of my pod, and to integrate with Git. Right? This is way too much to take in. So we're going to go through it slowly and try just to cover the basics so that you will feel excited about using the tool, and later go read more web pages about it. When you run Diesel, you can run diesel build. And when you run this tool, this command, you end up with a tarball. Just like if you said make dist. Other useful commands are test, which builds it and runs all your tests, or install, which builds it and installs your code locally, or release, which builds it and releases it to the cpan or anywhere else. All of these are about building your distribution, building the tar file. So how do things build? The build method in Zilla looks something like this. Gather all the files in the distribution, munge them, edit their content, collect all the metadata about the distribution, write all the files out, and you're done. And all of this is done by plugins. How do you decide what plugins you want? In Zilla, there is no default configuration. You can't use Zilla out of the box. You have to configure it and figure out how it works. And I think that's one of the fun parts, is deciding exactly how you want the task to work for you. Build a very personal set of preferences. But one place to start is to think about its basic behavior. This is the basic behavior. And its goal is to do things that almost everyone wants, but to do it in a way that will never edit the files you give it. So all the files you have written will be shipped just like they are, but it may build new files that you don't want to edit. So for example, it will build a manifest file for you. There's a manifest plugin that builds a manifest file. The manifest file is my least favorite thing in cpan distributions. I don't know why it's there. I always get it wrong. I forget to put things in it. I build a dist and I upload it, and there's two files in the distribution, meta and meta. Because I forget the manifest. This builds the manifest for you. It also builds the makefile.pl for you. And it puts in all of those ternary conditional operators so that you don't need to worry about which version of makefile added licenses or optional prerequisites. It takes care of all of that for you. It adds a license file so that people at Debian will like your distribution. It adds a README file, which I always forget to make. It builds your meta file, which is one of the most important things that it does, because it will get it can get your metadata from all sorts of places and put it together into one meta file in ways that are much, much easier than you could ever do with MakeMaker or module build or module install. The plugins that I like are the plugins that let you delete things you used to have to write. Package version will go into all of your libraries and add our version equals 1.2, whatever the version is. So you never need to update your files to track the version. Zilla will do that for you. Pod syntax tests. It will make tests to make sure that your pod syntax is good, but it will never make the user run them. It will always make the correct version of the test just today. You will never ship a broken test or a test that is out of date. Same thing for pod coverage. Auto prereqs is amazing. The auto prereqs plugin will scan all of your source, determine your actual prerequisites as best it can, and it's very good at it, and make your prerequisites in your meta file match what you actually use in your code. Auto version lets you pick a version automatically without thinking about what the next version should be. So nowhere do you say, I'm starting with version 1 and next will be version 1.1. It just does it for you. There are a number of these based on different ways people like to version. Next release is very simple, but one of my favorites. It puts a marker in your changelog file that says, the next version is here. And then whenever you actually release, it will put in the version you're releasing and the time you're releasing it at. So you only need to put in the changes, and it handles the silly stuff like the version number and the time. Dist will integrate with your version control, and it integrates at least with Git, Subversion, Mercurial, SVK, and I think there might be a few more now, which makes sure that you always commit your changes, always push your changes back to the remote, always check that you are up to date with the remote, always tag your releases, always have your files committed or checked, indexed before you keep going. Very useful. And finally, Podweaver. Podweaver I'll talk about a little longer because it's very powerful and allows you to delete a lot of garbage from your distribution. So here's an example module. I hope everyone can read this. No? This is a simple module, and it's so simple, in fact, that here is the only code in the module. Everything else is documentation. And if we start looking at it, what we'll find out is a lot of this documentation is crap. It does not require a person to ever think about it. For example, there's some red up there at the top. Those lines are setting the name and description of the module. Well, you don't need to type the name in. You named the file already. There's no reason for a human to type in the name. And the description is useful, but it shouldn't have to take up 4 vertical lines. So with Zilla, we drop those and we just put in a comment that describes the module. Next is the version. I like to see the version in the documentation so I know, looking at PerlDoc, what version I've installed. But that means every time I update the version in the Perl code, I have to update the version in the pod, which is ridiculous. Delete it. Next is the version assignment. Every time I want to update the distribution and release it, I have to edit every .pm file. This is a waste of my time. Delete it. These guys are okay. We're saying here head 2 method and head 1 methods. So we're building this large section with all our method definitions. That's fine, but it means we need to put all the methods together in one stack, in one order in the file. We should be able to document a method, near it in the code, but organize the code any way we want. So with Zilla, we're going to make a new command. I'm sure you can't read this, but it says equals method. So it's like equal head 1 in pod, but instead we say method. Later something will find all the methods, pull them out, put them together, and put them in one place. You could also do this for attributes and functions and other things you want grouped. Down here, this red, the author's name and the email addresses. Well, when you change your email address, do you want to go and edit every file that has your email address in it or add new authors? It's a waste of your time, so delete it. And the license, look how much space is in there for the license. And how many times are you going to go update the copyright year when you're changing the copyright year, or adding a new copyright holder, or fixing a typo that you had in module starter that you accidentally put into every PM file? Just delete it. And what you end up with is this. It fits on one slide so you could read it. And the ratio of pod to code is much better. And the only pod that is left, the only documentation still showing, are things that you needed to write. The description of the library, the documentation for the code that a computer can't write. You need to write that, so that's fine that it's still there. Everything the computer could write, we've deleted. And to make all of this work in your code, what you need to add to your Zilla configuration is this one line. So converting to Zilla, if you think this sounds interesting, is pretty easy. You make a dist ini with whatever configuration you like. You delete a whole bunch of files. Then you delete a whole bunch of lines from other files. Or you could use distzuki, which tries to do this automatically for you. Converting a dist to Zilla is very easy. Zilla also replaces module starter by letting you build new distributions. So just like we had these commands for releasing, we have diesel new for starting a new dist. It can't use dist.ini because there's no distribution yet. So it looks into your home directory for a profile. And the profile looks a lot like dist.ini with different kinds of plugins. So it's going to gather files, but these are all templates because they're different for every distribution. It's going to build you a dist.ini, and it's going to initialize a Git repository. And if you want to make a new distribution like this, it's going to end up calling code that looks a lot like the code that was used to build. Gets all the files, edits all the files, makes the main module, and writes it all to disk. These slides are not interesting. This is your global configuration for stuff everything has. Your name probably does not change very often, so you can go ahead and put in your global configuration. It will know your name, the license you like to use by default, your pause credentials, so no matter what distribution you're working on, you can release it and it will find the right information without having to copy this into all of your dist configuration. So again, edit it in one place, don't repeat it all over the place. That's what Zilla is all about. And to build this, all you need to do is run diesel setup. Once you've installed Zilla, you run diesel setup, asks you a bunch of questions, and you're done. When you run diesel new, it's going to print out some status. And when you look in that directory, you ended up with these files. And these are the only files that you really need with Zilla. You don't need a README in there. You don't need make file.pl. You don't need a manifest. You don't need anything except for the dist.ini, a changelog, and your code. And maybe tests. Tests are nice. Now I want to talk about how you make plugins. It's almost more useful to know how you make a plugin than to know the plugins that exist. Because once you understand how plugins work, figuring out what plugins you need is very easy. And writing plugins is easy too. And it's great. It's awesome. When I showed you this code, this is a bit of a simplification. Yes, it does gather the files, and it edits the files, and it collects metadata, and it writes the files out. But the way that it does that is that instead of just saying munge files, it says, get all of the plugins that are installed in me that do munging of files and use those to munge all the files. So every plugin that does the role file munger gets a chance. Zilla is built using Moose, so all the plugins have roles, which are like traits or subclasses. And if you want a plugin to do any particular behavior, you give it that role. So for example, it looks like this. You make a class that uses Moose, and it has that role. And now the plugin would show up as plugins that have this role. Here are some of the roles we've got. Roles for plugins that do stuff before you start, plugins that add files to your distribution, plugins that delete files from your distribution, or edit the files in your distribution, or figure out the prerequisites of your distribution. Every kind of thing that Zilla does is done by a role of plugins. And how do they work? What does a plugin look like? Let's write one right now. We'll make a plugin that anytime you build a distribution, it puts a file into the distribution telling you on what platform you built it. So you can look at a distribution you built and see this was built on Solaris, or Irix, or Linux, or Mac. And the plugin looks like this. We'll call it Zilla plugin built on. It's a Moose class, which uses the file gatherer role. The file gatherer role means the plugin adds files to the distribution. And it also means it has to have a method called gather files. And when it runs, it's going to build a new file for the distribution called built on, and the contents of the file will be whatever comes out of uname. Adds the file to the distribution, and you're done. This is the entire plugin. If you take this plugin and you want to use it, then in your dist.ini, you just say, built on. I want to use the built on plugin. And now you have a plugin right here that's going to make a file in memory, and when your distribution is built and uploaded, it'll contain the contents of that file. If you want to make the plugin take parameters, so for example, you want the built-on file to have a different name here or there, you just give it an attribute. It's a moose class. So you give it an attribute, and you use the attribute, for example, for the file name where you need it, and to pass that configuration parameter to the plugin in your dist.ini, you just use an ini parameter. So these become the attributes of your plugins, and the plugin can look at its own attributes for how to behave. And if you leave the parameters out, you get the defaults, just using the standard moose system. Let's write another one. This one's going to be a little more practical. We'll go through all of our files that we think are Perl executable programs and add shebangs to them. So they always start with #bang user bin Perl. This one's going to be a file munger. This one gets a chance to edit any file in your distribution, just mess around with its content. So it's got to have a method called mungefile. It gets passed a file, and it doesn't do anything unless the file ends with .pl. If it does, it gets the content of the file, and it adds $X to the front, which is going to be something like user bin Perl. So this plugin is going to find all your .pl files and add a shebang to the top. We might run another plugin, and this one is going to say, in every file, who built this distribution this time. It's going to look a lot like that last one, but instead of adding user bin Perl to the top, it adds built by RJBS, whatever the user is. And we can go into our dist.ini and add those two plugins. This becomes a problem. So we're going to add shebangs, and we're going to add blame. So if we start with a file that looks like this, and then we go and we add shebangs, and then we add blame, the shebang is in the wrong place. This is no longer going to run. What we need to do is swap the order of those two plugins so the order of their operation also changes. The plugin system is pretty stupid. It's the simplest thing that could possibly work. But the good news is, it does work. You need to pay attention to what you're doing, but plugins are so easy to write that it's very simple to keep the plugins small and always know just what they're doing. So, how much time do I have? Okay. This Zilla. It is, anyone?
Awesome.
Yes. We would also accept huge or stupid. If you want to get started with Zilla, the first thing I suggest you do is think really, really hard while you're reading the documentation. You want to find all the plugins you can and figure out what they do and how they work and which problems you need to solve. That is how I like doing it. Always start from first principles and figure out exactly what plugins you need. The other option is to use Distmilla. Distmilla is just like Distzilla, but it does have defaults. The defaults are all chosen by Migawa-san, and they're pretty good. I wouldn't use them, but a lot of people like them. He is much more conservative than I am. I add a lot of stuff to my distributions. And if you have any issues getting started with it, you can come and talk to us on IRC and our mailing list. We have a very nice tutorial. Now, I'm running short, so I can maybe give you a live demo, but before I do that, I'll stop now for questions, if anyone has any. Yes?
Auto-versioning, it automatically updates the version. What about, say, if you want to have like a major version update? Would we specify?
Sure. So the question is, how do you tell Distzilla, if you are using auto-versioning, that you want to do a major version upgrade? One of the roles that Distzilla has is called version provider. And that is a kind of plugin that picks a version. Most of these will let you override the version by using the environment variable v. So if I'm going to release version 2 of something that is currently version 1.012, instead of running diesel release, I run v equals 2.00 diesel release. And now we'll override that. There are other ways to do it. The version plugin that I showed earlier called auto version, a lot of people didn't like it when I was using it for about a year or two. Because the way it worked was, it had a fixed number, usually 0, as the major version. And the rest of the numbers were the number of years since 2000, followed by the current day of the year, followed by how many releases I've made that day already. So it was a meaningless number, and you couldn't look at two versions and figure out how much had changed. And a lot of people like to have, there's also 6 digits, 1.234567. So it's also hard to think about which version does what. What I use now is a plugin called Git version. And it looks at your tags. It looks at all the tags that look like version numbers, finds the biggest one, adds 1 to the smallest part, and that's your new version. And there are other plugins that do versions other ways. So you can have the version number in one of your modules. Some people like to put our version in one of their modules, and Zilla will pull it from there and add it everywhere else. So you edit the code one place, but not everywhere else. So you have a lot of options. Other questions? Yes?
Why auto preference collector collect strict?
What? I'm sorry.
Why the automatic preference collector collect strict and warnings?
So why does it collect strict and warnings? So the auto prereqs plugin, the way that it works is it uses PPI, the Perl parser. There's been talk of switching it to the new compiler library, but it uses PPI, and it finds things like any place that you said use or require, or a lot of other ways like extends or with that you would use in moo or moose. And it adds those as your prerequisites. So it starts off by saying everything goes into there. And the only time we remove things are when you hit a library that is not found in O2 packages. So if you tried saying cpanm config, cpanm would say there is no such thing as config, even though everyone has it. Well, strict and warnings are indexed. So if you use strict, we make strict a prereq. There's no harm in that. And the interesting thing is, thank you. The interesting thing is that if you say use strict, you can specify a version which allows you to do stuff like, well, strict is a bad example, warnings is a better one. The behavior of warnings changes between different versions. And you can look that up in Perl Delta and find out which version of warnings you need. And you can say use warnings 0.012 and get the specific version you need. And the prereq scanner will pick that up for you. It's true that strict and warnings are core libraries. There are a lot of core libraries, and sometimes they leave. So if you had been using Zilla and used switch, and we didn't put switch in your prerequisites, when Perl 5.12 came out and switch was gone, your distribution would be broken. So we don't try to remove core libraries. Some core libraries will probably never leave the core. Strict is not going anywhere. No one's going to take strict out of Perl. But rather than make a list of all the libraries we think will never leave, we just put them all in. Anyone else? Okay, well, I will probably skip the demo now. We're under 5 minutes. I really enjoy using Zilla, and the thing I like most is helping write new plugins that solve problems I never thought about. So if you have any cool ideas for plugins, you should stop me and show me, and we'll write some code. Thank you very much.